Okay, good morning. Can everybody hear me? So my name is Gary Lopes. I'm with Maycom Technology Solutions. I'm the Senior Director for RF Power Products. And today I was going to show you some 5 of the top new products that we've developed using gallium nitride on silicon carbide, along with some information on the RF life test burn-in process that we went through to demonstrate the MTTF of the products so that you know exactly how long are they going to last in your particular application. We have a whole line of GaN on silicon carbide devices. They're manufactured using a 0.5 micron silicon carbide type process. We design the devices in our own facilities, and then we have them foundried in a United States foundry for us to our exact specifications. The devices, of course, are very high breakdown devices. They have breakdown voltages in excess of 200 volts, so they're extremely rugged. They perform with very high power and very broad bandwidth and are very efficient. All the devices that you probably know are Class AB type configured amplifiers. They're a depletion mode device, so they do require a negative voltage on the gate. We have some circuitry that helps customers use that I'll tell you about in just a few minutes. Many of the devices are rated EAR 99, so they are exportable. Some of the devices that we have that exceed those limits can also be sold with a license, and we've had very good luck in doing that over the past year. So we sell a variety of different type devices. They're pre-matched devices, in other words, those devices that have internal matching to cover specific applications in specific bands, like for radar, avionics, or broadcast. We have unmatched devices for very broad band type applications, so those would be simply die inside of a package, both single-ended as well as push-pull Gemini. We have pallets. Pallets are, of course, palletized amplifiers that may use 1 or 2 devices, and we have what we call a smart pallet that I'll tell you a bit more about in just a few minutes. We've recently purchased a brand new load pull station with all the software to go along with that, so we're now starting to design and generate models that will be utilized with the products, and we'll be able to offer that to customers in the next few months. So as you can see, some of the devices there on the, we have the pallets, as I mentioned, discrete devices in it, and then finally some new plastic devices. We have GaN in plastic, which is sort of a new innovative thing that we think is going to have some real play in some applications where the cost may be a more sensitive issue. So the first device I'd like to show you is a 120 watt device. This is a device in a Gemini configuration. It provides 120 watts minimum, and we rate it from about 1 megahertz up to 2.5 gigahertz. You can see the performance there. It's conservatively rated, where we rate it at 120, and in reality it saturates up around closer to 150 watts. And then the gain across the band. Down at the low end of the band, it'll do 30 dB a gain. That's 30 dB a gain with good stability, excellent efficiency, very rugged, able to withstand at least a 30-to-1 mismatch at all phase angles. And then up at the high end of the band at 2.5 gigahertz, does around 13 dB a gain with the same rugged performance that you expect at the low end of the band. So a large variety of applications, both commercial like LTE, WiMAX, and so on. Milcom would be another perfect part for that. It can be used in commercial applications like broadcast as well as infrastructure. And then finally SATCOM and some radar applications as well. So a great general purpose device. One of the newest parts we have for L-band radar, covering 1.2 to 1.4, is our 425 watt device. This device provides excellent performance with gain in excess of 20 dB across that band. This is broadband performance I'm showing you, by the way, for an instantaneous bandwidth. So again, conservatively rated, we rated it at 425, but you can see it does well in excess of 450 watts in a saturated mode. And then finally, the efficiency is in excess of 60%, and that's drain efficiency. I should tell you also there's a follow-on part that's going to be coming here shortly in the next few months, and that's a 500 watt transistor that'll also cover the same frequency band. For S-band 2.7 to 3.5, this is a great part. This is a part that covers 800 megahertz of bandwidth. One of the things that you've probably not seen before out of an RF power device. So 120 watts instantaneous bandwidth from 2.7 to 3.5 gigahertz. Again, very conservatively rated. It's rated at 12 dB, and that's broadband gain performance in excess of 50% drain efficiency. And the 800 megahertz is a real broadband performance characteristic, so you can use it anywhere in that frequency band. We rate this at 300 microsecond pulse width and a 10% duty. We run it at about half an amp of quiescent current. And then finally, our smart pallet devices. This is something new that we've come up with over the past year, where MACOM has traditionally been a pallet manufacturer using 1 or 2 devices for radar-type applications. We took our GaN devices and added extra circuitry to it to make it even easier for customers to use. So on board, there's a negative voltage generator running off of the main bus of 50 volts, so you have your gate supply already there. We have sequential timing to protect it so that it only biases up the gate first before the drain, protecting the device should the power be removed. We have onboard programming for the biasing. So there are 2 serial ports that you can see right here, right there. We bias those. We set the bias at the factory for any unique characteristic that you may want in terms of running it at a specific quiescent current. And that's completely programmable, and once it's set, it's fixed, so we'll ship it that way to you. So it runs off of 50 volts in this particular case. It has this whole integrated circuitry, all self-contained. It does an excess of 600 watts of capability and 14 dB of gain across that band. So a brand new pallet with a lot of great features, and it's really plug and play, if you will. Finally, we have GaN and plastic, so something brand new. We have a whole series of GaN devices that are being put in plastic low-cost packages. In this case, it's a DFN package. We have 3 different products. We have a 30, a 50, and a 90-watt product. Those are all peak power performances with gain, again, anywhere between 14 and 30 dB gain where you're using it. This particular performance data we're showing you here is for 1100 to 1500 megahertz, which is a SATCOM type application. But these are internally matched devices, so they're literally workable for any frequency that you really want. So again, a very low-cost GaN performance capability for a variety of different applications. Just a few moments to talk about qualification. MACOM takes qualification very seriously. We recognize that GaN is a new technology with still a lot of things to be learned. But one of the things we wanted to do was to put GaN in a qualification process that we could stand behind and take to our customers and demonstrate what the reliability is over long periods of time. So MACOM took two levels of qualification, if you will. We took phase 1, which is qualification using mil standard 19500 for the various groups A, B, and C, which are both electrical and mechanical, and all the products that we ran those parts through those tests passed 100%. But probably the most important thing that we introduced was a phase 2, which was GaN tested in RF burn-in. And this was critical because it demonstrated the lifetime capability of GaN in a true application. Our test vehicle was a 30-watt GaN transistor running at 30 watts of output power. It was was tested at temperatures of 320, 300, and 290 degrees. And from that, we were able to generate an Arrhenius plot which demonstrated performance in excess of 600 years at 200 degrees channel temperature, at 114 years at 220 degrees. So this was important to recognize that this is real-time, actual RF performance characteristics that were measured to demonstrate the RF MTTF capabilities of the product over those periods of time. So it's something that we feel is important and that customers are really interested in understanding. It's a little bit of information about the testing itself. The testing was done in these specialized RF test fixtures that were developed. You can see the devices are right down in this slot right here. This is, again, a 30-watt RF device operating at full power at elevated flange temperatures. And you can see the device right here as a single-chip, unmatched device in a standard package. All this data is available on a white paper that was written by our staff at MACOM in Torrance, and that's available on the RFPD Richardson site for you to download and review. So again, we're growing the product line by leaps and bounds. We have literally a dozen products in process right now that'll continue to fill in on various applications. I want to encourage you, if you have specific applications for GaN, that maybe there's a product that is in our portfolio, to contact us, because we will develop specialized devices for specialized applications. We're going to continue to drive the product levels at L-band and S-band, in addition to avionics and let's say the 960 to 1215 band. We're going to grow the smart pallet technology capability and infuse that into multiple stage amplifiers, cascaded amplifiers for a variety of different applications. And then grow the plastic capability, because we feel the plastic's got some real play in the market space where low cost is really going to be an advantage in bringing GaN into a variety of different applications. So there you are. I hope that helps you understand our GaN product line a little bit better, and we'd like to answer any questions you may have. Tim?
The plastic package, is there any impact on the thermal performance?
No. As a matter of fact, we have some good thermal data that's available that we'd like to show you. The performance seems to be almost as good as those that are in the standard flange type packages. Those are all surface mount devices, by the way, so they're great for automated high volume type applications. Any questions? Okay, thanks very much.